Welcome to Age of AI, Politics, Law, and Society, hosted by Medlir Mema, Chris Lamont, and Young Diogenes, in association with the Global Governance Institute in Brussels.
Hello, I'm your host, Chris Lamont, joining you with Medlir Mema and our guest, Ritwik Gupta, a PhD student at the University of California, Berkeley, in both computer vision and public policy, with a focus on computer vision in chaotic environments such as disaster response and national security and the dual-use nature of AI for both civil and defense affairs. Ritwik is a member of the Berkeley AI Research Lab, a graduate fellow with the Berkeley Risk and Security Lab, a research fellow at Berkeley's Human Rights Center, and a fellow at Berkeley's AI Policy Hub. Welcome to the show, Ritwik. It's a pleasure to have you with us.
Thanks for having me here. I'm really looking forward to the conversation.
I would like to start with you telling us a little bit about what got you into this field before going into your research and work.
Absolutely. I was fortunate enough to begin my career at Carnegie Mellon University within a center called the Software Engineering Institute. And the Software Engineering Institute is the Department of Defense federally funded research and development center, which does research on behalf of the DoD. And FFRDCs are a very common thing. People might have heard of the JPL or the national labs, which are operated by NASA and the DOE respectively. And so the DoD also has its own at CMU, MIT, and some other places as well. And some of the first things I began working on were robotics for automatic evacuations of soldiers. There's heavy firefights and often in all sorts of unconstrained environments that are hilly and off-road and weird terrain. How do we get a robot to sort of get in there and automatically evacuate a soldier in the middle of a heavy firefight? And that made me realize just how terrible our existing machine learning methods were in these sort of chaotic and unpredictable environments. At the time, back in 2017, there was a lot of work being done in self-driving. I mean, that was like the self-driving boom. And all of it was on like, it's funny to say, but relatively neat road conditions, right? Despite self-driving not being a solved problem in cities, that's still so much easier compared to like random forests and hilly terrains and snow and night. And I realized that we need to do more about that. Like our perception stack itself is lacking. And I couldn't think of a better environment to do that research in than the world of disaster response. Especially with the DoD ties, a lot of that work is inherently very dual use. During a disaster like an earthquake, a lot of our assumptions are just thrown out the window, right? I may have had a map of the earth and I knew that point is like 2 meters off the ground. After an earthquake, that may no longer be true. There might be all sorts of smoke and haze, and all of our perception stacks just don't work in these environments where our assumptions have been challenged. So that's what really inspired me to do this work. And I've been lucky enough to be involved in this area since 2017.
And your work has spanned both the kind of the governmental and private sector as well. Can you tell us a little bit about that?
Yeah, I'm very fortunate that I get to have an academic life and a life in which I get to translate a lot of that technology into real applications via my roles in the government. And I get to bridge the worlds, right? A lot of academics don't talk to the government people and vice versa. And so a lot of my research that has been done in creating better methods on AI actually was initially inspired by a real problem in the field that was being sorely felt by various government agencies. So I was able to then take that technology, figure out how to solve that problem, and then also figure out how to solve the people's problem that was originating from in the first place. But then I also realized that I was spending a lot of my time actually not doing technical work, but doing policy work. CAL FIRE wants to use my algorithms to do damage assessment, but CAL FIRE doesn't have the budgeting or the resourcing for a person who knows how to use a Linux terminal, or they don't have a GPU, or they don't have the right authorities with which to use a satellite on domestic soil. And so I spent a lot of my time solving policy issues, and I realized that my colleagues in the governance world were out of touch with emerging technologies, and despite their best intentions, they couldn't keep up fast enough because the rate of progress was so fast. And I realized that I brought a unique perspective to policy, which was I knew exactly what the technology was, how it worked, having built it, and so I could do maybe a better job with my colleagues actually building better policies. And so my research spans that whole gap, right? Let's figure out what the problem is in the real world. Clearly there's limitations, and that's why we haven't solved already. Let's go build the new methods to solve that problem. And then let's see that all the way through to implementation by actually solving all the policy issues that are preventing the uptake of that technology.
You point to a disconnect between the policy world and practice. An example would be the use of concepts like foundational or frontier models by policy researchers and regulatory frameworks for AI governance. However, in your research, you argue that this kind of disconnect provides for an unstable foundation for regulation. Can you tell us a little bit more about this?
Yeah, thanks for bringing that up, Chris. We just recently published a paper on Archive. There'll be more iterations on it as we polish it a little bit more, but it's focused on data-centric AI governance. And specifically, we're pointing out the limitations of current AI governance strategies and how they're only model-centric. And not only are they model-centric, but they're built on definitions of models that are still shifting. So we're using the word foundation model despite the foundation of foundation models being shifty, and that doesn't really fly well. To break that down further, Rishi Balmasamy and the crew at Stanford released this paper that basically introduced the term of art foundation models into the world. And at the time that it was released, it was a hotly contested academic topic, right? Berkeley, all of us at Berkeley looked at it and said, wow, that's a great marketing effort. These are just pre-trained models. And it's basically just saying that they're basically marketing as like these models that now somehow have better capabilities than any other pre-trained model. And we didn't really agree with that. And if you look at the definitions of foundation model in their paper, they essentially say that it's a large model trained using self-supervised learning on a large amount of data. At some point, it demonstrates emergent capabilities. And it's all these different definitions that they put. And then they have all these case studies demonstrating the use of quote unquote foundation models. The problem is that the academic AI debate around foundation models has evolved quite a lot since those days, right? We don't know and we don't think that self-supervised learning is the only way by which you can have a model learn powerful generalizable representations. We don't know if a large amount of data is the thing that's needed to get these models to have powerful representations. We don't know if a large model is the only thing that matters, right? Smaller models might work just as well. And so as the definition of what is foundational changes, and maybe I'll make the point too, that a foundation for what? If I'm building a house, I build a very specific type of foundation. If I'm building a commercial high-rise, I have a very different type of foundation. So as my requirements for my foundation change, what is a foundation model in that case? And so when the academic sector, who is coming up with these terms, itself disagrees with the definitions, itself is evolving those definitions as new research comes out, and our governance documents are now using those same terminologies, except they're not going to be updated in any sort of reasonable amount of time. We are fundamentally building on a foundation that is irrelevant the minute that policy comes out. And that's limiting. We shouldn't be adopting terms of art as the thing that we rely on for governance. We should instead be finding more, and quite literally, we recommend the use of the word general purpose because that's really the real concern, but more general purpose words that get to the intention and not necessarily just the jargon, despite the jargon sounding cool.
So is it the case then that the regulatory focus is too skewed towards the bigger models, when smaller models can also cause significant harm? And the focus should be on intent over the characteristics of the model.
So I'll make a few caveats to that point. So the first thing we're saying is that stop using terms of art that are specific to AI research as your definitional basis, because those definitions are bound to change. And you're going to find yourself in a very awkward spot when a capability that you do want to be covered is argued to not be covered because they're using a different definition than you. So let's use definitions that are based on the intent and the outcome rather than is it a cool word just because it makes it sound cool. The second point we make is that smaller models are often just as capable or more capable than their large model counterparts for specific downstream tasks. And we also make this clear point that I don't want to call a model risky. I don't want to call a model harmful, right? Models by themselves are not risky or harmful. It's the combination of a person with malicious intent who is then using a tool to accelerate that harm that it results in some sort of harmful behavior. Just like how a hammer on its own is not dangerous. I'm using it to build a house. It's only once a serial killer takes charge of that hammer and starts swinging around that we say that's harmful. That's not good. Similarly, we've had technologies for decades now, right? We've had things like search engines. We've had things like databases that help us answer questions. So what is the marginal gain and risk that AI is offering that other technologies couldn't? Let's focus the conversation on that. What is unique about that? What are the thresholds that you're worried about that makes AI a unique tool that can accelerate risky behavior rather than preceding technologies? All of that to say that large models aren't the only things that are very capable. Smaller models are often just as or more capable for specific things. And they're not harmful on their own. They are just software on their own. It's only once they're used with a specific intent do they become risky or harmful. I would argue that like implicitly they're not risky technologies.
There was one other term in the original definition that you haven't mentioned. That's the emergent qualities and the aspects of these large language models. I think that's where perhaps people start using terms risks and harmful, because your analogy of the hammer is apt only insofar as those emergent qualities are not there. But if there are some, right, and that's where the conversation and a lot of the hype is about, is that there are these agentic kind of, models that can act on their own rather than just in the hands of a malicious actor. Are you saying that you're skeptical about the whole case, that in fact those emergent qualities exist in these models?
I'm not skeptical about that at all. Emergent capabilities do exist in models. The degree to which they exist and the degree to which they can function without the appropriate amount of data, that is what I'm skeptical about. If I were to train a 7 trillion parameter model on just Shakespeare, on just Hamlet, maybe it has emergent capability to generate other types of Shakespeare, like a Shakespearean type of dialogue, but I would really doubt, I'd really press a strong doubt button that it could ever generate a chemical weapon. It probably can't, right? The emergence has a limit, right? It's emergent to what? And a lot of our evaluations and benchmarks for emergence are really bad. In fact, the biggest debate in AI research circles today is just how bad our evaluations are for these really large capabilities that we don't even know how to properly define. Like, I don't think that emergence has a clear definition in academic literature that's quantifiable. And so I'm not saying that models aren't emergent, they are, but to what degree and then to what things can they be emergent to, like the like unrelated things, that's the big question mark. The other thing is that these models work. The reason they're so big, et cetera, is because they are to a degree memorizing data, right? They're memorizing key components of the data. And then there's this concern about agentic AI. What if it does things on its own? What if it's able to reason on its own? We're not at the point where a model sort of exists as a pure reasoning agent without having memorized any data, right? There's no such model which is a pure reasoner, but is only learning things when it's exposed to data for the first time. And so if you're worried about these models being able to do things that you didn't originally program them for, I would argue that they were programmed for it. You just didn't check your data well enough for a lot of these downstream tasks. So let's make data governance policies or model governance policies that are data-centric, that take into account the data they were trained upon, and not just focus on the model itself.
Yeah. Well, I think that's where some of the disagreements will be, right? Because even accepting, admitting any level of emergence implies there is some unknowns around the corner, and it's difficult to anticipate those. But I think you just touched on the issue of governance here, which I think is a very important one, because for better or worse, so much of the governance talk is all about these agentic models, as well as emergent characteristics and qualities. And so then the question I guess I have for you, and I think you hinted at this a little bit, but your view on most models of governance. I imagine you've been following up on that. California has been battleground of those kinds of conversations. I know that the governor has vetoed one of those bills that went through Congress there. What is your view when you look across a regulatory framework across the United States, but even globally, the EU AI Act, obviously more famously, what is your sense? What are they getting right and what are they getting wrong?
I think our policymakers are doing a remarkable job for the type of technology that they have to put a box around, right? The technology is moving so fast. It's like a cockroach skittering around on the ground, and putting a box around it is a really hard job, and they're semi-succeeding in doing that. They're clearly understanding what the potential harms are that are posed to society as a result of the use of these technologies, and they're even doing a good job of trying to understand the proxy metrics by which you could measure how powerful these capabilities are. I think the one thing that they're missing, however, is that the way that we measure the capabilities itself is flawed. And the proxy metrics that we're using are demonstrating trends that are maybe long-term true, but have all sorts of short-term reversals in those trends that enable a lot of loopholes. And so I think what's happening is that our policymakers are not AI people. They're not AI researchers. I would actually wager that 99% of them have never written a line of AI code in their lives. And so when you don't have that first-hand experience, it's really hard to understand the nuances of that technology. And that's not to say they're not doing a good job. Obviously, these are very educated, smart people who come from all sorts of other backgrounds. It's just that when the technology itself is moving so fast, how do you regulate it? I am a vision researcher at one of the world's best AI labs, I would say that I live at the state of the art. And even still, my weekly reading list in just my niche of literature is about 70 papers a week. I do not get through it. So how do policymakers have other things to worry about? How are they going to get through it?
How then would you envision a data-centric approach to regulation?
That's a great question. So I would say that a lot of AI regulation today is underspecified, which results in regulatory hammers that are way too broad. So again, I'll make the case to you that if I were to give you a 10 billion, 10 billion, or 10 trillion parameter model, and it was only ever exposed to Shakespeare, the model is not going to be capable for much beyond Shakespeare.
Right.
However, if we were to adopt the sort of policies that are recommended today, either the Biden EO or the EU AI Act, or even SB 1047 that recently failed, that 10 trillion parameter model or that 10 billion parameter model would be covered regulated capabilities. Why? I can easily argue that's causing no harm. There's no harm in people quoting bad Shakespeare at all, besides the obvious cultural harm. Yeah. And clearly what we're missing is the data part, right? We're regulating on f of x, where x is model quantities, but it should be f of xy, where y is now data quantities. And data, I would argue in many ways, is an easier quantity to measure. Right? And there's a big asterisk on that, because what does data mean when given to a transformer, tokens, blah, blah, blah. But I would still make the claim that data is data and it's more or less absolute, whereas how well a model performs as a function of parameter size is a constantly shifting battleground. We max out our GPU capability, so we build these really big models that are expensive to train. Then a whole group of us sits down and says, well, you don't need that, this can be faster, that can be better. And we end up with a model that's a tenth of the size, but performs 50% better. And that's just how research progresses. But obviously, the second capability won't be covered if you just adopt the regulation as are proposed today.
Right. And from focusing on data, to get back to the hammer analogy, you get a better sense of the intent, right? You can infer back from the data that somebody is training a model on as to whether or not the intent might be harmful or not, correct?
And this is the crux of the problem, Chris, which is that we are just not aware of what's in our data sets anymore. So, for example, back in late December of 2023, early January this year, researchers at Stanford demonstrated that Lion 5B, which is one of the largest data sets we use to train our diffusion models, contain verified instances of child sexual abuse material. And this is actually something I theorized months ago when I was helping the FBI sort of circumscribe what these capabilities could be. And then these people at Stanford then went out and proved it. And this was because researchers with good intentions were scraping the internet to build a public resource. And they knew that the internet contains porn, because in their paper, they actually went ahead, classified images as porn or not porn. And then they just kept that label and kept those images in there. What they couldn't imagine was that the internet contained child sexual abuse material, right? Child pornography. I don't like using that word because pornography is consensual. This is all non-consensual material. Yeah. And okay, well, that was 5 billion data points that contain hundreds of verified instances. Companies like Google and Meta and OpenAI and even startups are scraping trillions of data points across the internet. And they make the argument that it's impossible for us to know what's in that data set. That's not a wrong argument. Of course, even if you had a team of 1 million people, you're not getting through those trillion data points at any time reasonable. But that doesn't absolve me of my responsibility. If I were out there trawling the surface of the ocean with a net, and I was killing a whole bunch of manatees in the process, I can't just be like, oh, sorry, my nets are so big, I can't do anything about it. All these organizations need to look into their data sets, because I guarantee you, even if they're saying that our data sets don't contain, like our models are safety trained to not generate chemical weapons, their data sets contain that information in the first place. And rather than trying to solve this problem in post, where they train their model on this data and they try to safety train all that away, and then there's all sorts of loopholes around that, if you just deleted the data and you verified the data wasn't there, the models wouldn't perform that well in the first place. So let's nip the problem at the root rather than trying to come up with all these other things to solve it. I've already rambled on long enough, but I'll make one more claim, and maybe a bit provocative, is that the companies don't want to look inside their data sets. The minute they look in and they're like, there's CSAM there, now they're liable, because this isn't a Section 230 covered practice.
Right.
The internet for generative AI purposes, not for social media purposes. And once they find out that there's that stuff there, they have to do something about it. So it's better to just close your eyes and pretend it doesn't exist than to figure it out. And that's not to say they're not trying to, but I don't think they're trying hard enough.
And what incentives would be needed to get them to try harder? Because as you said, there's absolutely an incentive for them to not know.
The incentive, I think, for a company would be safer capabilities, right? I think all of them want to build capabilities that are safe, reliable, and something that doesn't harm public safety. That's the number one goal. And so I think internal incentives could also be like better promotion of these capabilities. I think externally, there just needs to be a bit more of a regulatory focus, right? These companies need to face consequences for the stuff they're doing. And that's not to say that like that's necessarily the most healthy relationship. Like you can't always just hold a hammer over companies' heads and say like, if you don't perform, like we're going to kill your business. At the same time, I mean, and this is not a unique thing, right? Companies have been very poorly handling consumer data for decades now. I think it's high time that the government does something about data regulations.
Okay, well, this has been really, really interesting. I really, really appreciate Ritwik, everything you said. And you have been advocating, at least the way I hear it, for turning our attention and focus and not just being obsessed just with large language models or other large data, but also focus on smaller models. And I know you have vast experience, as you pointed out, both the public and private sector, with coming up with solutions to actually real problems. And I would really love to just talk about a couple of those because I think they're fascinating for everybody, I think, to understand. As a principal AI scientist of the Defense Innovation Unit, you have worked in the past on XView 2. Perhaps you're still working on it. You can update us on that. But first of all, what is XView 2? And then how does this kind of relate to disaster response? I mean, the world is in commotion now. There's been historic disasters everywhere throughout the world, more recently even here in the United States, but also in Europe and across the world. How can these technologies actually help us in an increasingly kind of unhinged world?
Yeah, let me get to that in 30 seconds. I just want to make one more point.
Please. Yeah.
So right now in Vienna, the TED AI event is happening. And one of the sessions at TED AI is the power of small language models, SLMs. What a head fake. And actually the panelists are like the people who made these LLMs in the first place. If you're a policymaker and you've been pitched multiple times and high stake contacts and at fancy dinners from all these company lobbyists that LLMs are a big threat, and now all of them are saying, well, actually, SLMs are the future. What a head fake. What do you do now, especially when you've committed to writing all these policies for large models? Anyways, XView 2 was some of my first research at CMU in conjunction with the DoD, which was focused on solving this problem of making damage assessment a safer and faster task for first responders. Damage assessment, believe it or not, is one of the most critical, time-sensitive things that a disaster organization has to do in America, especially, or actually around the world, but especially in America, because that's how we get a lot of our federal disaster management funding. We have to tell FEMA and other agencies like how many buildings were damaged and how many are going to be damaged as a result of this disaster. And if that estimate is near correct, you get your funding. If it's not, then you go back and forth till you get it right. And all that time, you don't have the money that you need to fight the fire or fight the hurricane or whatever. And so we basically created the first method by which you could take high resolution satellite imagery, which had a very wide footprint of area covered, and you could automatically assess damage to buildings after natural disasters. And it was amazing work, I say so myself, but to the point where it's now been adopted by dozens and dozens of disaster response agencies all around the world. And even companies like Microsoft and Google now offer this as a service for free to the public through their collaborations with, let's say, Google works with the World Food Program, and Microsoft's working with many different disaster response agencies directly. We've been able to take this task that took months and reduce it to seconds and actually get a lot more accuracy in the process itself.
That's great. And another, in line with that, I think it's another platform, the XView 3 platform. It's about fishing, illegal fishing. And just, can you talk to us a little bit more about that? I know that this is a lot of your work, but for a lot of us, again, we just get so caught up on these debates about LLMs and others that we lose track of the fact that much of applications of AI technologies can actually be very effective in real time and devoid of the politicking around it, but solve real world problems. And so that's why I'm asking these questions, moving from the more abstract discussions to the more specific ones. So on the disaster response one, obviously, but international fishing, there's a lot of waste there and a lot of loss there. How can technologies help us there? What is the nature of the problem and what is the nature of the solution?
Those are great questions. And as a result, I'm not about to go into a long explanation.
Go ahead.
You're ready. So let me first tell you why XView exists as a series of challenges, right?
Excellent.
In the DoD, at DIU, the Defense Innovation Unit specifically, our charter is to bring the newest and greatest commercial technologies that are being built by our startups around the US into the DoD, such that we can just benefit from existing commercial technology that with a few tweaks can be used for military purposes as well. And there's two-way gain there. When a company has a commercial offering, they're competing on the free market, and any sort of improvement they make to the product for that market that also benefits the DoD without us having to pay them extra money for that same upgrade, and vice versa. When the DoD comes in with our requirement and says, I want you to make this small change, I want you to be a little bit more cyber secure, or I want you to maybe make this a little bit more rugged, etc., or make this more work with one controller or any type of controller rather than one controller, all their customers benefit because those are all mutually beneficial things. And so DIU is at the forefront of technology. A lot of the technologies that are just now getting on the commercial market, we are already adopters of. And so XView, the reason it existed was our space portfolio was bringing in companies like Planet and Maxar and others into the DoD and give them contracts and capabilities with the DoD to replace some of our very expensive national technical satellites. And at the time, the world, this is 2017, 2018, the world really wasn't using some of these high resolution ultra-optical images for much. And so our goal was twofold. How do we do something that's academically, like from a machine learning perspective, very difficult, and such that we're accelerating the rate of change in the machine learning sector? And how do we also enable the adoption of these satellite images across the world as well? And so XV1 did fine-grained object detection. XV2 did building damage assessment because working in occluded environments where there's smoke and haze, and you're doing very fine-grained segmentation was a difficult ML problem, which led us to XV3, right? XV3 was made with the realization that electro-optical imagery is not always tactically useful, right? Electro-optical imagery is passive. It works because the sun is beaming photons and then objects are beaming photons back, and sensors to passively soaking those up. What happens when it's night and there are no photons? What happens when it's cloudy and the clouds also reflect photons? And when it's a disaster, there's usually always smoke or clouds or haze. And so electro-optical imagery turned out wasn't proving to be useful in the hours and days when a disaster was occurring. It was proving useful in the week after. So it's still strategic, it just wasn't tactical. And so what our perspective was, synthetic aperture radar imagery, which is an active form of imaging, you can then view the Earth in day or night or through clouds. How do we get people to build methods that work with synthetic aperture radar instead? And if you went and talked to your leading machine learning researchers at Berkeley or Stanford or MIT, and we did, and you asked them if they knew what SAR was, they just look at you blankly. Vision researchers don't work with that. And so we wanted to incentivize the world to build better technologies for SAR, and there's two ways to do that. One is to give them a lot of money to solve the problem, or two, you give them a lot of data. So with SV3, we said, let's do both. Let's build a prize challenge with the task of detecting dark vessels that are committing illegal, unreported, unregulated acts of fishing. And let's have machine learning researchers actually do that in a prize competition where if they win, they get a whole bunch of money. And that's exactly what we did. Similar to XV2, we built a massive data set. We built a prize challenge that ran for 3 months, and the world responded. XV2, we had about 2,400 participants. XV3, we had 2,600 across the world. And the models were improved by like 200, 300% in performance. And now those models, we've since made them better, we've made them faster, and we've deployed them into platforms, government platforms that are looking out for dark vessels all around the world. To the point that with the aid of our models, we've actually helped in the intercept of dozens of illegal fishermen, human traffickers, drug smugglers, all sorts of things, because we've been able to use this technology to illuminate the oceans. These models aren't LLMs. The number of parameters are in the order of single or tens of millions, and they only solve one task, which is object detection. In fact, if you asked an LLM to solve the same task, it couldn't do it. So when we talk about frontier capabilities, in this case, the LLM is not the frontier capability. XV3, a specific model from XV3 is the frontier capability. And the other point I'd like to make is all this is dual use. This is a very civil application, detecting illegal fishing. If I can detect a fishing or non-fishing vessel, I can also use it to detect whether or not that's a military or non-military vessel. And in fact, XV3 is also being used to detect Russian vessels in the Black Sea. And we're sending all the information to our colleagues in Ukraine. So all the technology is dual use, right? The military and civilian use exists together. And so if I'm concerned as a regulator about the military uses, I also have to remember that AI is used for a lot of good and the capabilities need to be treated accordingly. And also, if I'm concerned about frontier capabilities that can be used for harmful behavior, then I can't forget these small models, right? If I want to stop the military use of models for vessel targeting, well, you got to look at things like XV3. But the only thing we look at now for some reason is LLMs, which makes no sense to me.
Right. Thank you.
Ritwik, there's so many more questions we could ask you, but we are running short of time at this point. I would like to thank you for joining us and for illuminating a data-centric approach to looking at AI and alerting us to the need to focus on intent and discerning intent through data sets. Ritwik, thank you so much for joining us. That's it for today's show. Join us next time for another discussion at the intersection of law, society, and politics. Until then, stay human.